This is The Hidden Life of Trees by Peter Wolben. We're in chapter 15, In the Realm of Darkness. For us humans, soil is more obscure than water, both literally and metaphorically. Whereas it is generally accepted that we know less about the ocean floor than we know about the surface of the moon, we know even less about life in the soil. Sure, there's a wealth of species and facts that have been discovered and that we can read about, but we know only a tiny fraction of what there is to know about the complex life that busies itself under our feet. Up to half the biomass of a forest is hidden in this lower story. Most life forms that bustle about here cannot be seen with the naked eye, and that is probably the reason we are not as interested in them as we are in, say, wolves, black woodpeckers, or fire salamanders. For trees, though, these creatures are probably way more important. A forest will have no problem doing without its larger inhabitants, deer, wild boar, carnivores, and even most birds wouldn't leave any yawning gaps in the ecosystem. Even if they were all to disappear at once, the forest would simply go on growing without many adverse effects. Things are completely different when it comes to the tiny creatures under their feet. There are more life forms in a handful of forest soil than there are people on the planet. A mere teaspoonful contains many miles of fungal filaments. All these work the soil, transform it, and make it so valuable for the trees. Before we take a closer look at some of these creatures, I'd like to take you back to when soil was first created. Without soil, there would be no forest, because trees must have somewhere to put down roots. Naked rock doesn't work. And loosely packed stones, even though they offer roots some support, cannot store sufficient quantities of water or food. Geological processes, such as those active in the ice ages with their sub-zero temperatures, cracked open rocks and glaciers ground the filaments down into sand and dust until finally what was left was a loosely packed substrate. After the ice retreated, water washed this material into depressions and valleys, or storms carried it away and laid it down in layers many tens of feet thick. Life came along later in the form of bacteria, fungi, and plants, all of which decomposed after death to form humus. Over the course of thousands of years, trees move into this soil, which only at this stage can be recognized as such, and their presence made it even more precious. Trees stabilized the soil with their roots and protected it against rains and storms. Erosion became a thing of the past, and instead, the layers of humus grew deeper, creating the early stages of bituminous coal. While we are on the subject of erosion, it is one of the forest's most dangerous natural enemies. Soil is lost whenever there are extreme weather events, usually following particularly heavy downpours. If the forest soil cannot absorb all the water right away, the excess runs over the soil surface, taking small particles of soil with it. You can see this for yourself on rainy days. Whenever water is brownish in color, this means it's carrying off valuable soil. The forest can lose as much as 2,900 tons per square mile per year. The same area can replace only 290 tons annually through the weathering of stones underground, leading to a huge annual loss of soil. Sooner or later, only the stones remain. Today, you can find many such depleted areas in forests growing in exhausted soils that were cultivated centuries ago. In contrast, forests left undisturbed lose only 1 to 14 tons of soil per square mile per year. In contact forests, the soil under the trees become deeper and richer over time so that growing conditions for trees constantly improve. This brings us to the animals in the soil. Admittedly, they are not particularly attractive. Because of their small size, most species cannot be detected with the naked eye, and even if you go out armed with a magnifying glass, you won't have any luck. It's certainly true that beetle mites, springtails, and pseudocentipedes are not nearly as engaging as orangutans or humpback whales, but in the forest, these little guys are the first link in the food chain and can therefore be considered terrestrial plankton. Unfortunately, researchers are only peripherally interested in the thousands of species discovered so far and given unpronounceable Latin names. Countless more species are waiting in vain to be discovered. Perhaps, however, we can take comfort from this. There are still many secrets in the forest that lies directly outside your back door. Let's take a look at the little that has been brought to light so far. Let's take the aforementioned beetle, or Orbatid, mites, of which there are about 1,000 known species in European latitudes. They are less than 0.04 inches long and look like spiders with inadvisably short legs. Their bodies are two-tone brown, which blends in well with their natural environment, the soil. Mites? That brings up associations with household dust mites, which feed on the flakes of skin we shed and other waste products and may trigger allergies in some people. At least some of the beetle mites act in a similar way around trees. The leaves and fragments of bark trees shed would pile up several yards deep if it weren't for a hungry army of microscopic creatures ready to pounce on the dead trees. To do this, they live in the cast-off leaf litter, which they devour voraciously. Other species specialize in fungi. These creatures crouch in small underground tunnels and suck the juices that ooze out of the fungi's fine white threads. Finally, beetle mites feed on the sugar trees share with their fungal partners. Whether it's rotting wood or dead snails, there is nothing that doesn't have its corresponding beetle mite. They appear everywhere at the intersection between birth and decay, and so they must be considered essential components to the ecosystem. Then there are weevils. They look a bit like tiny elephants that have lost their enormous ears, and they belong to the most species-rich family of insects in the world. In Europe alone, there are about 1,400 species. For the weevils, it's not so much about eating as it is about childcare. With the help of their long snouts, the little creatures eat small holes in leaves and stems where they lay their eggs. Protected from predators, the larvae gnaw little passages inside the plants and grow in peace. Some species of weevil, mostly those that live on the forest floor, can no longer fly because they have become accustomed to the slow rhythms of the forest and its practically eternal existence. The furthest they can travel is 30 feet a year, and they really don't need to be able to travel any further than that. If the environment around a tree changes because the tree dies, all a weevil has to do is make it to the next tree and continue nibbling around there in the rotting leaf litter. If you find weevils, you can be sure the forest has a long, uninterrupted history. If the forest was cleared in the Middle Ages and later replanted, you won't find these insects, because it would simply have been too far for them to walk to the next old forest. All the animals I have mentioned so far have one thing in common. They are very small, and therefore their circle of influence is extremely limited. In the large old-growth forest that once covered Central Europe, this didn't matter at all. Today, however, people have altered most of the forest. There are spruce instead of beeches, Douglas firs instead of oaks, young trees instead of old ones. The new forests were literally no longer to the animals' taste, and so they starved, and local populations died out. However, there are still a few old deciduous forests that act as refuge where the original diversity of species still exists. All over Germany, forestry commissions are trying to grow more deciduous than coniferous forests once again. But if mighty beeches are to herald change and stand once again where spruce now topple in storms, how will the beetle mites and springtails get back to these places? Not by walking there, that's for sure, because they cover barely 3 feet in a lifetime. So is there any hope at all that one day, at least in national parks such as the Bavarian forest, we will once again be able to marvel at authentic old growth forest? It is entirely possible. Research carried out by the students in the forest I manage has shown that microscopic organisms, at least those associated with coniferous forests, can cover astonishing distances. Old spruce plantations show this particularly clearly. Here, the young researchers found species of springtails that specialized in spruce forest. But my predecessors here in Hamel planted such forests only 100 years ago. Prior to that, we had predominantly old beech trees, just like everywhere else in Central Europe. So how did these conifer-dependent springtails get to Hamel? My guess is that it must have been birds that brought these terrestrial creatures as stowaways in their plumage. Birds love to take dust baths in dead leaves to clean their feathers. When they do this, the tiny creatures that live in the soil must surely get trapped, and they are then unloaded during the dust bath in the next forest. And what works for animals specialized for spruce probably also works for species that love deciduous trees. If, in the future, more mature deciduous forests are allowed once again to develop undisturbed, then birds can see to it that the appropriate subletters show up again as well. In any event, the return of the teeny little creatures can take a very, very long time, as the latest studies out of Kiel and Lüneburg attest. More than 100 years ago, oak forests were planted on the Lüneburg Heath on what had once been arable land. It would take only a few decades for the original framework of fungi and bacteria to settle the soil once again, or so the scientists assumed. But far from it. Even after this relatively long time, there are still gaping holes in the species inventory, and this deficit has grave consequences for the forest as the nutrient cycles of birth and decay aren't functioning properly. Moreover, the soil still contains excess nitrogen from the fertilizers once used there. True, the oak forest is growing more quickly than similar stands of forest located on ancient forest soil, but it is markedly less robust when it comes to issues such as drought. We don't know how long it will take until true forest soil is created once again, but we do know that 100 years is not enough. To make it possible for this regeneration to happen at all, you need preserves with ancient forests free from any human interference. These are places where the diversity of soil life can survive, and these refuges can be the nucleuses for recovery in surrounding areas. And incidentally, no real sacrifices need to be made to make this happen, as the community of Hamel has demonstrated for years. They have put entire old beech forests under protection and found innovative ways to market them. Part of the forest is used as an arboreal mortuary, where the trees are leased out as living gravestones for urns buried under them. To become part of the ancient forest after death. Isn't that a wonderful idea? Another part of the preserve is leased to firms as their contribution to protecting the environment. This makes up for the fact that the wood itself is not being used, and both people and nature are happy. Efforts to offset the costs of protecting and restoring forests in the 21st century are happening around the world. Some combine utility with education. Tourists in the Maya Biosphere Reserve in Guatemala employ residents who would otherwise be cutting down forests to sell the lumber and grow food in the clearings. Some combine prestige with preservation. In Scotland, you can buy a piece of forest originally owned by the nobility to keep the lumber companies out and usher in the return of the ancient Caledonian forest. Yet others involve unlikely partners. The U.S. Department of Defense contributes to the National Fish and Wildlife Foundation's efforts to restore longleaf pine ecosystems in the American Southeast on the grounds that forested buffers around military bases contribute to military readiness. There are so many ways that forests can be kept both undisturbed and productive. That's the end of chapter 15. Next time we'll be in chapter 16, carbon dioxide vacuums.